Some of you have been asking me, how is it that you know to pick the right U when you're doing a U substitution problem? So I thought I would go ahead and put together a video and do some review problems and pick the wrong U on purpose so that you can see why it's the wrong U and also how to correct it. So here we go. Problem number 1 is on the board. I'm taking the integral of secant cubed x tangent x dx, and so I'm going to go ahead and pick the wrong U. And in some cases you don't know it's the wrong U until you get through the substituting part. So here we go. Du turns out to be secant squared x dx. All right. So you go ahead and look at what you were, the integral you started with, and try to somehow come up with this integral in terms of U, and try as you might, you can't ever get to a secant cubed with this U substitution. So you give up, you go back, you don't give up completely, and you say, okay, well, let's go ahead and see what happens if the U I pick is the secant of x. Let's see if that's any better. So du equals secant x tan x dx. Okay, and so I can go ahead and rewrite the original integral before I do U substitution as secant squared x times secant x times tan x dx. Now why did I do that? Because then it's really easy to see how the U substitution is going to work. Secant squared x will simply be U squared. Secant tangent x is simply du. And I wrote dx, du. Alright, so I should go ahead and finish this. We're going to go ahead and take the integral using the power rule, so I get u cubed over 3 plus c, and then of course because the integral is indefinite I need to go back and replace that u with secant x, and so my final answer is that. Okay, so that's a great example of how you can pick the wrong U, recognize it's the wrong U, and then finish the problem correctly anyway. So let's go ahead and look at an integral that involves e. So we have e to the x over 1 plus e to the 2x dx, and I think we've actually done this problem on a worksheet in class. You probably remember me saying, when in doubt, if you don't know what to pick for your u, try the power of e or try the denominator of the fraction, and unfortunately in this problem neither of those works. So what we're going to do is pick the denominator of the fraction and show you how it doesn't work, and then go back and do it correctly. So if u is 1 plus e to the 2x, then du turns out to be 2e to the 2x, and that's the chain rule with e to the 2x dx. And then 1/2 du equals e to the 2x dx. Unfortunately, this u isn't the problem. The du is, because once we make this fraction 1 over u, we still in the numerator have e to the x dx, and there's no way we can turn an e to the 2x dx into an e to the x dx. So we cross that out and we start over. So this is one of those where you recognize that it is a form of the derivative of the inverse tangent. So let's do this. Let's go ahead and pick u as e to the x, and then du turns out to be e to the x dx, and then this integral becomes nothing more than 1 over 1 plus u squared du. Okay, can you see that? If u is e to the x, du is e to the x dx, and so e to the 2x becomes u squared. Well, that's nothing more than the inverse tangent of u plus c. And then of course, because it's an indefinite integral, we're not done until we go back to the original e to the x plus c. Okay, one more example, and this one involves power rule. Let's say we've got the integral, this is the third one we're doing, and this is t squared times the square root of t minus 3 dt. And so your choices for u are either t squared or t minus 3. Okay. The problem, what you are most drawn to is picking u equals t squared, because then you know that 1/2 du equals t dt, and the power of this part, at least under the root, is the first power of t. So that might seem like a good choice to make. Unfortunately, it's the wrong choice, and here's why. There's no way that we can go from u equals t squared, 1/2 du equals t dt, to the square root of t minus 3 dt. What does that equal? All right, so there's no configuration of this information that will get you to that. So even though the power of this that's under the root is 1 degree less than t squared, that's not the u to pick. So here's what we do. We pick u to be t minus 3, so du turns out to be dt. And then on the aside here, we're going to go ahead and not only solve for u, we're going to solve for t. And so t becomes u plus 3. Right? So now when we do the u substitution, we get that t squared will be u plus 3 squared. And then the t minus 3 that's under the root will be u to the 1/2 du. Okay, see if that doesn't make sense, how we put this information together to get this